Okay, so basically what you have to do in this video, sorry, in this question, um, you have to work out what the graph would look like based on the description. So what it's done, which you might find helpful, is it says that it moves in a straight line from rest, and it. So we know that it's not going to change direction or anything complicated like that. That first bit is not really a sort of stage of the journey, but it tells us a little bit about it. So now it tells you that it So this is the first bit of information really to plot on the graph. It travels from constant acceleration. So that means constant acceleration. So it's a velocity time graph. So we know it's going to be a straight line. And the other bit of information, let's use a different color here. It's going to be 4 seconds in a straight line, and it's going to reach a velocity of 5 meters per second. So our first plot is here. And what I've done is I've done a dotted line from the 5 meters per second which it reaches, and another dotted line for the where it reaches it at 4 seconds. So it's going to be here. So let's put I'll put a green cross through there. It's a bit difficult to see in this case because unlike this one over here, it subdivides it into groups of 5, and so it's much more easy to count. But we're going to have to do it using these dotted lines. It's the best way to do it. Now it says it travels with a constant acceleration from there to there. It's going to be a straight line. So we can draw that by clicking Smart Drawing, and we'll draw a straight line from freehand from here. And it obviously doesn't look straight at the moment, but when I let go, it straightens it out for me. So that's the first bit. It then said it slows down, and this bit's a bit tricky. It slows down for 2 seconds. Well, first of all, if it's done it for 2 seconds, it's going to go from 4 to 6. So let's draw a vertical line here, that's not a very good vertical line, but clearly need to have a few less coffees. If I click on that, and we're going to change it to a dotted line, and we'll make a different, let's make it that color. So something's going to happen along that line, because it said it's going to decelerate, so it's going to go down. But we need to work out what it's going to go down to, with an acceleration of 1 meters per second squared. That should say squared, but the formatting didn't let it work, obviously. So now we're going to work out what would be the final velocity. In this case, the initial velocity, which I'm going to call u, we haven't talked about this yet, but the initial velocity, let's do that again and turn off Smart Drawing a moment. The initial velocity is it's 6, it's 5 meters per second for that part of the journey. So u means starting velocity from here. And what we want to know is what is it going to get to? So the final velocity. The final velocity we say is v, and that's what we don't know. But we know that the acceleration is equal to the change in velocity divided by time. And so we need to calculate the change in velocity. So by rearranging it, the change in velocity is going to equal to the acceleration times time, which is going to be 1, because the acceleration, in this case it's -1 actually. -1 because it's decelerating.
What course are we going from?
So we know it's going to stop. It's going to start here, but we're trying to work out what it's going to drop to. So the acceleration is -1, and the time is it tells you it's 2 seconds. So we know the change in velocity is going to be -2 meters per second. Well, it started at 5, so it's going to go down to 3. Let's draw about that question mark. Oh, I wrote 2. I meant to say 3 meters per second. Okay, so now we know what it's going to drop to. It's going to drop to 3. So we go on, zoom in on this graph. Well, let's draw another dotted line so I can get it right, because unfortunately I think that's 3, but I'm not sure if it's that one. I think it's that one, but just to be sure, we're going to draw a. Oh, let's turn smart drawing back on. I will pick a pink as well. Smart drawing. Okay, yeah, thank you. Go away. Yeah, I think. Well, I can't remember what I said now, but anyway, it's that one. There. Oh, I need to turn smart drawing off now. Must be a quick way to turn smart drawing on and off, but I haven't learned it yet. Okay, and now it's turning back on again because I'm going to draw a. Because we know it's going to go down, right? There it is, and we don't want we want that to be not a dotted line, and we want it to be green. In fact, don't we? Like the other one. So make it solid, which is going to be that tells you whether it's solid and so on. So that is the one that we want. Okay, so far so good. What else does it say in the explanation? So we've done that. We've done the first and we've done the second. So that's the second there. Oh, smart drawing again. It then hits a wall and stops. Well, it doesn't really say how long it's going to take to stop. So we're going to say that when it hits the wall, it takes a total of 1 second to stop. So we've got 1 more second to play with. So let's say it goes down to here. So we'll pick up green pen, turn on smart drawing, and there. So that should get you, because in reality you don't ever get, because if it went vertically down, that's like saying it's an infinite deceleration. You can't do that, obviously. So that is the answer for that question.